Hi everyone, and welcome back to the series where we solve data problems in both SQL and Pandas. This series includes all medium difficulty data questions. Today's challenge is to find the DNA pattern recognition. We have a table sample with a sample ID, DNA sequence, and species. We need to create 4 more columns. For each column, we need to identify sample ID with the following patterns. The value should be either 0 or 1. We need to find the sequences that start with ATG and with either TAA, TAG, or TGA, sequences containing the motif ATAT, and sequences that have at least 3 consecutive G. If the DNA sequence column has one of these sequences, we write either 1 or 0. In Pandas, pattern recognition is a typical regex task. Microsoft SQL, however, doesn't have regex functions. In SQL, we need to use case-when statements in order to identify these 4 columns. We write a select statement. We order the result by sample ID. And in the select statement, we output sample ID, DNA sequence, pieces, and here we will create 4 additional columns with case-when statements. For the first column, case-when DNA sequence is like, and here we have to define the sequence should start with ATG. We write ATG, and important, we should not forget the $sign. The $sign indicates that after ATG you can have any letter, any character, or sometimes maybe no character at all. But the beginning of the sequence must start with ATG because we don't have any additional characters in the beginning. So if the DNA sequence starts with ATG, then we write 1, else it's 0, and we end the case-when statement. This column is called has start. We copy-paste and we change the case-when statement. Case-when DNA sequence like TAA, and it should be in the end. So here we act vice versa. We allow any character in the beginning with a $sign, but not in the end. The end must be TAA. Or, so we write the keyword or, the DNA sequence ends with TAG, or the DNA sequence ends with TGA. Then we write 1, else 0, and this column is called has stop. Next case-when statement is if the sequence contains ATAT. We need $signs in the beginning and in the end because we allow any character in between. It also means that if it ends with ATAT, there is no characters, it will be allowed. This column is called has ATAT. And the last case-when statement is when we have at least 3 consecutive G. So we allow 3 Gs in any part of the sequence. It can be in the beginning, can be in the end, or in the middle. The name of this column is has GGG. Here we forgot the like keyword. And now we are ready to run the query. We successfully solved this problem in SQL. Now let's move on to Pandas. Pandas provides the str.contains method, which accepts regular expression patterns. This is extremely powerful for bioinformatics tasks involving sequence motif searching. We start with creating new columns. First, we create has start column. For this column, we check the sequenced DNA. We use the function str.contains, and inside we use regex patterns. The caret sign in the beginning matches the start of the string. So the start of the string should be ATG. We should write S-type integer in order to allow either 1 or 0. If we don't use S-type integer, we will have Boolean expression, true or false. Now we copy-paste it and we create the other 3 columns. We will just slightly modify inside the regex expression. We are creating right now has stop. And the DNA sequence should end with TAA. We use $operator, which matches the end of the string. So with the $sign, we say that these 3 letters are in the end. We also allow 2 other sequences. So the O operator is just a pipe, and the sequence can end with TAG or it can end with TGA. Next column we create is called has ATAT. For ATAT, we just check if the DNA sequence contains these 4 letters. We don't write anything in the beginning nor in the end. the method contains check for the sequence. And the last column we create has 3 consecutive Gs. Now we are ready to return the result, and we return samples with sorted values by sample ID. Let's run the code. We successfully solved this problem in Python Pandas. Which syntax did you prefer for this specific problem? Case 1 statement in SQL or str.contains method in Python Pandas? Let me know in the comments.